Hello everyone and welcome to today's tutorial. Today we're going to explore a fundamental concept in web development and networking, HTTP payloads. Whether you're just starting your journey in programming or looking to strengthen your understanding of how data travels across the internet, this video will break down everything you need to know in simple, easy to understand terms. In this video, we'll cover everything you need to know about HTTP payloads. We'll start with the basics, what HTTP is and how it works. Then we'll dive into what exactly a payload is and why it matters. We'll explore the structure of HTTP requests and the different types of payloads you might encounter. I'll show you practical examples of how to work with payloads using popular tools and programming languages, and we'll look at real-world use cases where payloads are essential. By the end of this video, you'll have a solid understanding of this fundamental web concept. Let's start with the basics. HTTP stands for Hypertext Transfer Protocol, and it's the foundation of data communication on the web. Think of it as the language that computers use to talk to each other over the internet. When you type a URL into your browser or click a link, your computer sends an HTTP request to a server, which then sends back an HTTP response with the requested information. This request-response cycle is happening constantly as you browse the web, even though you usually don't see it happening behind the scenes. Now let's talk about payloads. In the context of HTTP, a payload is the actual data being sent or received in a request or response. It's the what of the communication, the actual content that matters. For example, when you log into a website, your username and password are the payload being sent to the server. Think of it like sending a letter. The envelope and address information are like the HTTP headers, while the actual letter inside is the payload. The headers help route the information correctly, but the payload is what you actually want to deliver. An HTTP request has a specific structure. It starts with a request line that includes the HTTP method, the path, and the HTTP version. Then come the headers, which contain metadata about the request, like the content type or authorization information. After the headers, there's an empty line that's indicated by CRLF, carriage return line feed. And finally, there's the body, which contains the payload. This structure is important because it allows servers to understand exactly what the client is requesting and how to process the information being sent. There are different ways to send payloads in HTTP requests. With GET requests, the data is included in the URL as query parameters. You've probably seen this before. It's the part of the URL that comes after a question mark, like in a search URL. GET requests are great for retrieving data, but not ideal for sensitive information since the data is visible in the URL. POST requests, on the other hand, send the data in the body of the request, making it more secure for sensitive information like passwords. Payloads can be formatted in different ways too. JSON is a structured format that's easy for both humans and machines to read, while form data is simpler, using key-value pairs. Let's look at what an actual HTTP request looks like, under the hood. Here we have a POST request to a login endpoint. We can see the request line, the headers including host, content type, and content length, and then the empty line indicated by CRLF. After that empty line comes the payload. In this case, a JSON object with username and password fields. The CRLF is crucial because it's what tells the server that the headers are done and the payload is about to begin. When you're working with APIs or debugging web applications, seeing the raw HTTP request like this can be really helpful for understanding exactly what's being sent. Now let's look at how you would actually send HTTP payloads in practice. With QRL, a command line tool, you specify the POST method, the URL, the content type header, and then the data itself. In Python, using the popular request library, you can create a dictionary for your payload and pass it to the POST method with the JSON parameter. And in JavaScript, using the fetch API, you specify the method as POST-T, set the content type header to application/JSON, and then stringify your JSON object for the body. Each of these approaches accomplishes the same thing, sending a payload to a server, but they're suited to different environments and use cases. So where do we see HTTP payloads in the real world? One of the most common examples is logging into websites. When you enter your username and password, that data is sent as a payload to the server for authentication. Messaging apps also use payloads extensively. When you send a text, image, or video in a chat app, that content is sent as a payload. And when you upload files to cloud storage services like Google Drive or Dropbox, the file itself is sent as a payload in the HTTP request. These are just a few examples. HTTP payloads are used in countless applications every day to transfer data between clients and servers. To wrap up, let's recap what we've learned. HTTP payloads are the actual data being sent in requests and responses between clients and servers. They can be formatted in different ways, like JSON or form data, and they can be sent in different parts of the HTTP request depending on the method being used. GET requests include data in the URL, while POST requests include it in the body. Understanding how payloads work is essential for anyone working with APIs, web development, or networking. It helps you build better applications and debug issues more effectively. That's it for this tutorial on HTTP payloads. If you found this video helpful, please give it a like and consider subscribing to the channel for more tutorials like this one. If you have any questions or if there are other topics you'd like me to cover, leave a comment below. I read all of them and they help me create content that you want to see. Thanks for watching, and I'll see you in the next video.